a burnout. Let's demonstrate how we test the insulation resistance. We begin by measuring the insulation resistance between the windings. For this, we use a high-voltage insulation tester, or Mega. To prepare the instrument, set the output voltage of the Mega to 500 volts and select the Meg-ohm range. Clip the test lead onto one end of the start winding and connect the other lead to one end of the run winding. Press the test button and note the reading on the Meg-ohm scale. It must read greater than 1 Meg-ohm to be acceptable. A reading less than 1 Meg-ohm indicates a leakage path between the two windings. Now unclip the Mega lead from the start winding post and connect it to the other end of the start winding. Test the insulation resistance again. The reading should be greater than 1 Meg-ohm. A lesser reading is indicative of an insulation breakdown. Remove the test lead from the run winding post and connect it to the other end of the run winding. Once again, test the insulation resistance between the windings and ensure that the reading is greater than 1 Meg-ohm. Remove the test lead from the start winding and connect it to the other end of the start winding. Test the insulation resistance once again using the same procedures. Record the resistance readings and conclusions on the checklist after each measurement is taken. Next, we test the insulation resistance between the windings and the motor frame or earth. Begin by attaching one of the Mega test leads to the frame of the motor. A good electrical earth point is usually available inside the terminal box. Then, with the other test lead, probe the ends of each winding, the centrifugal switch and capacitors. Record each measurement and your comments on the checklist. To meet acceptable standards, all the resistance readings obtained must be greater than 0,5 Meg-ohms. Any reading less than half a Meg-ohm suggests a possible insulation breakdown in the electrical system to earth. After the break, we'll deal with the mechanical test procedures. Welcome back, as we next discuss mechanical checks that should be performed on a motor. We begin with the bearing test. To check the bearings, rotate the motor shaft by hand and listen carefully for any abnormal noises which may indicate worn bearing surfaces. Then, test the shaft for lateral play by moving it from side to side or in and out. There should be no appreciable movement if the bearing is in good order. Next, perform a visual inspection of the shaft and keyway. Check the condition of the keyway for excessive wear or damage. Then, using a dial gauge indicator, check the condition of the shaft to ensure that it is not bent in any way. There should be no deflection beyond approximately 0,02 mm under normal circumstances. Next, examine the stator frame, end shields and grease housings if fitted. Check these parts for cracks, breaks, or missing through bolts or fixings. Check the condition of the fan blades for cracks or broken blades. Look carefully for cracks and broken or missing parts on the terminal box. Check that the motor nameplate is firmly secured to the stator frame and that the information is legible. Remember to record the results of each test. Any faults or defects must be noted on the checklist. This brings us to the end of this module, so let's summarize the key characteristics of capacitor induction motors. Firstly, the motor can be configured as capacitor start, resulting in a motor with good starting torque. Secondly, as capacitor run, resulting in a motor with good running torque. and thirdly as capacitor start and run, combining the high torque advantages of both capacitor start and capacitor run motors. This brings us to the end of Module 1. Practice the procedures that we have described and demonstrated on motors in your training area. You can learn more about AC and DC machines by viewing other programs in this series.